Hello everyone, my name is David. I'm a product manager at Apacer. Today I'll be talking about Apacer's product and technologies from application perspectives. And our primary topic for today is intelligent transportation systems. Our agenda will explore the concept of intelligent transportation systems, including which types of applications are covered in this segment. Then we will look deeper into what applications are used in your daily life and what Apacer can offer. Now let's get into the first topic of today, the concept of ITS. We all know that transportation in the modern world covers a wide variety of applications, geographical challenges, and country-specific issues. So when we discuss ITS today, we will limit our scope to land-based integrated transportation systems. Intelligent transportation systems, or ITS, consist of three main systems, utilizing advanced electronic, communication, information, and sensor technologies to integrate people, traffic, and vehicle management strategies. The goal is to improve the safety of transportation systems. First is Advanced Traffic Management System, ATMS. This system gathers traffic status and sends it back to Traffic Control Center via network infrastructure. It can remotely manage highway off-ramp lighting signals and traffic controls. Second is Advanced Traveler Information System, ATIS. Users can plan their routes via apps, navigators, or internet to check upcoming traffic status in their cars or homes before actual departure. Third is Advanced Vehicle Control and Safety System, AVCSS. This system is similar to autonomous vehicles, including ADAS and sensors around the vehicle to improve safety. Combining the three systems together, we can implement them in public and commercial fields. Advanced Public Transportation System, APTS, combining ATMS, ATIS, and AVCSS and applying them to public transportation systems to improve service quality, enhancing operation efficiency and increase passenger counts. It mainly includes vehicle monitoring, vehicle GPS locations, and fleet management. Commercial Vehicle Operation, CVO, combining ATMS, ATIS, and AVCSS and applying them to commercial transportation systems such as trucks, taxis, and ambulance to improve safety and operation efficiency. Here are some of the typical applications you might see in the application of transportation: navigation, counting cameras, digital signage, black boxes, video surveillance, passenger information systems, control centers and servers, unmanned parking lots, automated fare collection, communication systems, traffic, and fleet management. Now we will take some application examples we have seen just now and see how were they implemented in our daily lives. The first application is automated fare collection. This system is widely used for train or metro stations. It contains interactive kiosk machines for users to find their desired information, ticket vending machines to purchase tickets to their destination, automated gate controller to verify ticket validity, and passenger information system to check their train status in real time. Besides these machines, you can also see from the illustrated image that there are still some applications working in the background, such as IP cameras, network switches, and servers. The logs of ticket selling records, passengers' entrance records, and video footage are being sent to control centers, which will be stored in the server. Here's a tip. Whenever you see a machine running a software with a user interface or an operating system, it's certain that there are storage devices inside. According to our research, a lot of these applications are equipped with a 2.5-inch SSD and mSATA device sockets. After we have passed the gate and moved on to the platforms, here are some of the applications we can see on trains. Passenger information systems are also installed in train cabins so passengers can catch all important information whenever necessary. There are also IP cameras on trains, which transfer video footage mainly via a 5G network, while stations mostly still use LAN to transfer videos. Next is bus and fleet management. First application is the driver monitoring system. It records the driver's working status, making sure no incidents harm the driver. Then there's a 360-degree panoramic camera, capturing everything on the bus. A fare collection machine can sense the NFC chip on your cell phone and pay your bus fare digitally. This machine usually employs micro SD cards for storage. Next is the passenger information system, located at the front and middle of the bus, letting passengers know the status of their trip. A navigation system is also very common on commercial vehicles, planning routes or reminding the driver about the traffic ahead. Counting camera is a new emerging industry. It's built on the entrance and exits of public transports, and it counts people coming and leaving the vehicle. Last but not least, there will be a terminal to collect all of this data and sending it back to the control center via 5G network. All data will be stored in the server for future analytics, and the person who works at the control center can determine what further actions are required. For example, if counting camera counts too many people riding the bus during peak hours, the fleet management system will decide right away whether or not to send an extra bus to prevent bus stations from being flooded by crowds. The next application is the smart parking lot. This type of application is built with a lot of sensors, and all data logs will be transferred to the control center. When you first enter, there's a plate recognition system, which will take a photo of your license plate and display your plate on the screen when you are paying the parking fee. In the parking lot, you will see a lot of digital signs to let you know how many parking spaces are vacant on each floor. You will also see a light indicator showing different colors to let you know instantly where you should go to find a parking space. Lots of management software is convenient for applications that need whitelisting, as they might rented parking spaces monthly. And those who are not in the whitelist can be considered as parking temporarily. The last application for today is a navigation app users can install on their cell phones. This app allows users to access highway traffic cameras in real time, so they may decide what route they want to take before departure. This type of app is usually available in Android and iOS versions, and not only on phones, but also in cars' infotainment system, so it can also be used commercially. Micro SD cards are typically used to store map data on this application. What can Apacer offer for transportation systems? Apacer has a premium software package. It's called the Double Barrel Solution. It consists of two programs, Core Analyzer 2 and SSD Widget 2.0. Core Analyzer 2 is a software that can analyze application workloads by analyzing the command the SSD had received. And SSD Widget 2.0 can monitor many SSDs' health status. With these two software programs, users can know their application from head to toe and anticipate any potential risk in advance. And don't worry, Core Analyzer doesn't record any data. It only records command types, so you may understand your host behaviors better. This software package is available in Apacer's SATA and PCIe product lines. Many form factors are supported, including 2.5-inch, M.2, mSATA, and CFast. Core Snapshot is a system disaster savior. It's highly compatible with all operating systems and can back up and subsequently recover not only an OS, but also all data on an SSD. But what's most impressive is that it can carry out the entire recovery process in just 1 second. This can be triggered via various ways such as SSD widget, an external button, or via a cloud portal. Apacer's supported model is called the SV25C, and supported form factors include 2.5-inch, M.2 2280, and mSATA. Apacer also developed a technology called SLC Lite X. We chose industrial-grade 3D TLC and picked out the highest quality of NAND flash. Then our engineering team optimized firmware structure along with the enhanced ECC handling algorithms to achieve this success. While our competitors are offering 30K PE for similar technology, we have surpassed everyone else and offer the highest endurance there is, 100K PE. As you can see from the slide, endurance is 33 times more when compared to conventional 3D TLC, while costs are down 86 to 92% as compared to SLC. Now, users will be able to purchase an SSD which has the best cost-performance ratio for their application. Since SSDs are often deployed in demanding environments, power disruptions may occur unexpectedly and potentially cause catastrophic damage to the data in the drive. To ensure data integrity and the stability of data transmission in the event of power outage, Apacer developed two sets of technologies. A multi-dimensional protection approach. When an unexpected power failure occurs, the firmware protection mechanism of Data Defender technology is duly activated and cuts off data transmission from the host. Once power supply is resumed, the protection mechanism will rebuild the mapping table to ensure the integrity of the firmware as well as the data already written into the NAND flash media. In addition to the firmware protection mechanism, to further safeguard the in-process data, Apacer's CorePower circuit and tantalum capacitors provide a backup power source. This hardware approach can ensure data transmitted from the RAM cache to the flash storage remains uninterrupted in the event of sudden power outage. Other general requirements are value-added features such as conformal coating and nano-coating technology, which improves survivability. Wide temperature operation is also broadly implemented on most of Apacer's products. If there's any other special requirements, I'm sure our strong R&D team can fulfill your customers' requests. That's all for today. Thank you all for joining our presentation. See you next time.